Okay, so in this video, what we're going to do is we're going to graph a rational function that has an oblique asymptote. Okay, let's first factor this thing. So we have x times x plus 2, right? And that's going to be over x minus 1. Okay, let's get down the important information. So we're going to start with the where the x-intercepts occur. They occur at, let's see here, the zeros of the numerator are x equals 0. And x equals negative 2. All right. Okay, and the next thing we're going to do is find the y-intercept. And what we do is we sub 0 in for x. And if we do that in this case, notice the numerator is going to be 0, the denominator is going to be negative 1, so that'll give us 0. Okay, vertical asymptotes. All right, we're looking at the zeros of the numerator. I'm sorry, the denominator. In this case, we only have one vertical asymptote, that being x equals 1. Okay. Now we already talked about at the beginning of the video that we don't have a horizontal asymptote. We have an oblique asymptote, and the way that we can tell that is if the degree of the numerator is greater than the denominator, we have an oblique asymptote. All right. So the way that we're going to find that in this case is going to be synthetic division. Now, we could use long division, but since the divisor is of the form x minus k, we're going to go ahead and take advantage of that and do it the easier way with synthetic division. So let's see here, my oblique asymptote. Right, and so here we're going to take 1, we're going to divide that into the numerator. So we have 1, 2, and 0. And bring down the 1, so we have a 1 here, 3, 3 with the remainder of 3. So the oblique asymptote is going to come from this piece right here, and that's going to give us the equation y equals x plus 3. Okay, so now we are ready to graph. Okay, so let's go ahead and graph the information that we have so far. Okay, so we have an x-intercept at 0. The origin here at negative 2, so let's see 1, 2, so at negative 2, and the y-intercept is at the origin as well. Okay, so that doesn't change. Let's see, we have vertical asymptotes at x equals 1. Okay, so let's go ahead and put that one. Let's see, we have 1. Here's 1, okay. And then we have a vertical asymptote at 1. Let's go ahead and plot that. So we have a vertical asymptote here at 1. Okay, and then our oblique asymptote. Alright, so let's draw on the oblique. Now the oblique asymptote is actually an equation of a line. And so this has a y-intercept at 3. So let's see here. Let's see, 1, 2, 3. And let's see. Let's get some points here on this thing. So, like I said, the y-intercept is at there. Slope of 1, so we're going to go up 1, right 1. So let's see, up 1, right 1, right about here. And I know that we have the x-intercept for that line is going to be negative 3, so a little off, but we'll live with it. So here's that oblique asymptote. Is this the equation y equals x plus 3? All right. So now, let's see. So now, what happened to my, whatever reason, this line just disappeared. I have no idea why. Okay, let's put that back in. Okay, now we need to figure out what's going on here with this graph. So what we can do is we can make a number line. Okay, so let's make a number line here down below. And what I'm going to do is I always plot my vertical asymptotes and my x-intercepts. Okay, so I plot my vertical asymptotes. Let me just label this here. This x-intercept was -2, 0, and this was 1 here. So I want to plot those. So I have -2, I have 0, and I have +1. And I know this is my vertical asymptote, and these are my x-intercepts here. And I'm just going to pick some numbers in between. So let's say x equals -3, x equals -1, x equals 0.5, and x equals 2. Okay, so if I pick, let's say, x equals -3, what I'm going to do is I'm going to sub that into the factored form of this rational function. So if we focus up here on the factored form, let's suppose I do sub in a -3. Well, if I sub in -3, okay, then this factor will be negative. Now let's change the color on that. Okay, so let's see. So if I do that, then this factor will be negative, right? Because that'll be -3. This will be -3. So -3 plus 2 is another negative. And then the denominator is going to be -3 minus 1. That's another negative. So we have a positive up top divided by a negative. So that's going to be negative. Okay. All right. Now if we use -1 this time, let's see. Well, the first factor is still negative. The second factor this time is going to be positive. And the bottom is still going to be negative. And so we have a negative over a negative. Now that's going to be positive. Okay. Now if I pick 0.5, let's see, if I pick 0.5, then the first factor now is positive. The second factor is positive, but the denominator is still negative. So we have a positive over a negative is going to be negative. And now if we pick 2, well, first is top is going to be positive, positive. The bottom is going to be positive now. And so now everything is going to be positive. All right. Start with the leftmost portion of this number line from -infinity to -2. Well, that tells me it's negative. So what that means is that from -infinity up to -2, it's below the x-axis. Also, I know that my function, or at least the graph of the function, needs to approach this oblique asymptote. All right, so what's going to happen is it's going to go from, let's say, the negative, and it's going to approach, it's going to approach that asymptote like that. Now, between -2 and 0, it's positive, so it comes above the x-axis. And you see this other 0 right here? It needs to come back down towards that at some point, so it's going to turn and come back down, touch. And then from 0 to 1, it's negative. And remember how things work around the vertical asymptotes is as we get closer to those, we either go to -infinity or positive infinity. But since this is always negative between 0 and 1, it's going to go towards -infinity like this. Okay, now from 1 to infinity, so this portion of the graph, it's always above. So we have a couple of options, and one option is for it to be in this region right here, but that's impossible because first of all, it is always positive, and if it were down in this region, then it would have to eventually approach, it would have to go to -infinity and cross the x-axis, and we don't even have another x-intercept, so that's clearly impossible. So if it's above the x-axis at all times, and it needs to approach both of these asymptotes, the only way that can happen is if the graph is in this region here. Okay, so here it's always above, and it approaches both of those asymptotes. All right. Okay, and that's how we graph a rational function with an oblique asymptote.